Precision measuring instruments are tools used to measure physical quantities with a high degree of accuracy and reliability. These instruments are essential in fields like manufacturing, engineering, construction, and research, where precise measurements are critical to ensure quality, functionality, and safety. Linear measuring instruments include vernier calipers, which measure internal, external dimensions, and depths with an accuracy of up to 0.02 millimeters or 0.001 inches. Micrometers are used for extremely accurate measurements of thickness or diameter, with a resolution as fine as 0.001 millimeters. Height gauges measure vertical distances or heights on a flat surface, often used with a surface plate, while depth gauges measure depths of holes, slots, or recesses. Angle and alignment instruments consist of protractors, which measure angles, with both mechanical and digital versions available. Clinometers measure the slope, tilt, or angle of a surface, and combination squares are versatile tools for measuring angles of 45 degrees and 90 degrees, as well as depths and lengths. Surface and finish measuring instruments include surface plates that provide a reference plane for precision measurements, dial indicators that check flatness, alignment, and runout, and surface roughness testers that measure the smoothness or texture of a surface. Gauge-based instruments feature dial gauges used to measure small linear distances or deviations, feeler gauges that measure the gap width between two parts, thread gauges that check the pitch and accuracy of threads in screws or bolts, and plug and ring gauges that verify internal and external dimensions of parts. Length and distance instruments comprise steel rules for direct length measurements, measuring tapes that are flexible and used for longer measurements, and laser distance meters that measure distances using laser technology with high accuracy. Force and torque measuring instruments include torque wrenches that apply a specific torque to a fastener, force gauges that measure the amount of force applied to an object, and dynamometers that measure torque or power output of engines or motors. Optical and advanced instruments feature coordinate measuring machines, CMM, for 3D measurement of objects with extreme accuracy, profile projectors that magnify and measure part profiles using shadow or light projection, optical comparators used to inspect part dimensions visually, and digital calipers and micrometers that provide electronic readings for faster measurements. Applications of these instruments span engineering and manufacturing, ensuring parts meet precise tolerances. The automotive industry, verifying dimensions and alignments of mechanical components. Aerospace, measuring high-precision parts for safety and functionality. Construction, ensuring accurate layout and alignment in buildings, and research and development, measuring physical quantities in experiments and prototypes. Tips for using precision measuring instruments include regular calibration to maintain accuracy, proper handling to avoid dropping or applying excessive force, cleanliness to keep instruments and surfaces free from dirt, consideration of environmental factors as materials may expand or contract, and proper storage in protective cases to prevent damage.